Hi everyone, welcome back to my YouTube channel. I am studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering, pursuing my third semester. Other subject is data structure and application. Topic I've chosen is queuing theory based vehicular traffic management system. The title is Queuing Theory Based Vehicular Trafficking Management System through Jackson Network Model and Optimization. Author is Golam Rabiul Alam and Tajim Mustari Suma Ik Mahatab Uddin and Amin Khan Siam and Zahid bin Mohbab and Muhammad Mehdi Hassan. Pages are from 1,36,018 to 1,36,031. Publication date is on 29 September 2021. So the agenda of today's PPT is on the based on the above topic is abstract, introduction, literature review, system model, methodology, stimulation and experimental results, eh, references and conclusion. First, let's start with the abstract. Traffic congestion is increasing over populated urban areas. Our traditional traffic management system can no longer solve this problem. However, this problem can be solved by converting the road networks into queuing networks. This paper proposes the use of an open Jackson queuing model, which can be equated with our existing road network to calculate the waiting time of vehicle in the network, which can be further processed to put the network into an optimized state. Our implementation designated a set of services rate of a range from possible service rates of each road within the network of this designated service rates used to calculate the waiting time. Various combination of service rates of different roads produce multiple waiting times. We select the combination set of service rates which has the lowest set of waiting time. This set of time rates is also compared with quadratic optimism problem of the same road network to evaluate implementation's accuracy. So let's go with introduction. In modern times of Dhaka city, the exponential increasing vehicular traffic congestion has been seriously alarming factor for the entire nation. Traffic blockage is a basic situation and it is transformed into a typical marvels in Bangladesh, particularly in Dhaka city. Dhaka city traffic framework is viewed as one of the most disordered ones on the planet. The inhabitants are constrained to experiment the torment in terms of physical and mental stress. Besides, financial setbacks is also experienced by the people and it takes a toll to mental health. Valuable working hours are lost. Constructed a generic road network model and converted into a equivalent open Jackson queuing network model. Determined an efficient service rate based on vehicles arrival rate. Optimize the overall waiting time of the road network model from the equivalent queuing works model. Observed negligible deviation with comparing the solution obtained from the quadratic optimism algorithm of the same model. So let's move on to the literature review. Traffic congestion is increasing in overpopulated urban areas. Our traditional traffic management system can no longer solve this problem. However, this problem can be solved by converting node road networks into queuing networks. Queuing networks are an effective technique for studying the efficiency of ride sharing or vehicular application transport networks, communication networks, and so on. Increased traffic signal time reduces the traffic intensity, resulting in less delay on the such routes channels during morning and evening rush hours, step to reduce the traffic congestion. The next we on to the system modeling, a road traffic model. As we are trying to solve the traffic problems through Jackson queuing network optimizing theory, it is a best way to get intuition from the real life example. As we can see, there are many roads. Road 1, road and road 4 are connected, both road 2 and road 3. we can also see that road 2 and road 3 are separated, connected to some other roads apart from road 1 and road 2. Road 4. Those roads can have external vehicles entries and can move other roads apart from road 1 and road 4. In the given figure below, every road has a traffic system with different operating time and service time. Moreover, vehicles can choose to move from one road to another road connected other connected roads. So the amount of cars road 1 has get split between road 2 and road 3 and other road. Similar rule apply for all other roads in this network. So basically, if a car tries to move to another road or destination, one or more lines of car has to wait. We try to optimize this situation by reducing the amount of time of a car has to wait in the network. So queuing network model, using the intuition of the figure, we can consider each road has a queue. Each queue is connected to another queue, creating a queuing network as a whole. We try to optimize for each of and every queue in the Jackson queuing network to find what should be done to reduce the waiting time. In figure 2, we can see that very simple transformation of roads into queuing networks, which represents our previous example. Here are Q1, Q2, Q3, and Q4 as individual queuing length, customer arrival rate, and a service time rate in this queuing network. The probability of moving Q2 to Q3, from Q1, the external available rates determines the rate of Q2 and Q3. For Q4, the arrival rate would be determined by summarization of probability of moving Q4 from both Q2 and Q4. Methodology, system workflow. In the very beginning, we will stimulate the arrival date data to optimize mean waiting time of the customer by determining service time. As we are not using the real-time arrival data, we will use MM1Q to implement the Jackson's network. Our Jackson network will an open network as a real road traffic does and does not work on the closed networks. Then we determined how much the service time should be provided in order to optimize the mean waiting time of the customer in the network W. After that, we will implement the optimization theory according to the function and minimize the number of customers in the network N. Now, next we will use the optimized value n to predict the value of w. Finally, we will evaluate both results to see if the match will come to an conclusion. After that, we will implement an optimization theory according to our function to minimize mean number of customers in the network n. Next, we will use the optimized value n to predict the value of w. Finally, we will evaluate both the result to see the match and will come to a conclusion. We propose the queuing model to be used as a Jackson queuing model. Along with each individual queuing holds the properties M and M1Q. The network is open network when the external arrival rates can enter the network with comes from the Poisson distribution, and customer can also have the probability to leave the network, otherwise it is only closed network. Jackson network also uses FIFO algorithm, that is first come first out algorithm, as a severe discipline, because first come first out is a main algorithm of the queuing network. Each queue system has an independent, which means severe can differ from queue to queue. So here is using Poisson's distribution, the model of Q using the Jackson's is made, determine the service time, optimization, waiting time of the customer is also determined, and then implementation of the theory based on these calculations of W and N. After we find out the N, we can predict the W value, that is a customer in network, and the result evaluation is made. The stimulation and the experimental results, considering four different arrival services rates have been in the table 3. So based on the arrival rates and the waiting time and the signals and the distance, these all are calculated using the Q model and modology. Conclusion: traffic congestion has been critically hampering the lives of millions, if not billions, in many world and the developed and developing countries around the planet. However, the developed countries are not far away from facing this problem, as it is uprising in this country as well. Both the population and the quantity of the vehicles in the world are increasing day by day. So there's no going back without facing this crisis. The only feasible solution to this situation is to deal with this problem efficiently. The traditional hard coded traffic management and the signaling system has proven ineffective and inefficient to resolve this problem. Our proposed model is going to relate a traffic system which can open Jackson queuing network to virtuality create a model traffic network. Then our proposed model will process this data using our formulated equation from our research and optimize the customer waiting time using quadratic optimization. Finally, our proposed model will provide dynamic traffic feedback and management decisions depending on current vehicle density and other correlated variables. To conclude, the proposed model focus on implementing an autonomous and intelligent traffic management system which will reduce and optimize waiting time in traffic junctions and signals to face the challenge of the continuously expansion around the globe. I thank you everyone for watching this video full.